Hello, this is video 5 of the Beginning Artificial Intelligence series. This video is going to cover image manipulation. Image manipulation is important for any computer vision project, which is why I wanted to cover it before we get into more advanced Keras and TensorFlow, but also if or when I begin the Artificial Intelligence project series, it would be helpful to already understand the basics of image manipulation. This module you can see on the screen is built on top of OpenCV, which I import right here, and will make image manipulation and handling a little easier than raw OpenCV. It will also, as you can see right here, make it so you don't have to type as much. Alright, so now let's just get into it, and we can open up command prompt, activate our environment, and type Python. We can then go from here and import the image module, and now we have all these functions here. I'm going to load two images which I have in a directory that this is in video 5, and it will be on the GitHub too. To do the function to do it is load, so we can load the two right like that. Now we have x1, x2. You can see they are NumPy ND arrays, especially if we do this. And you can get the D type right here, which images are uint8 unsigned integers, which are 8 bytes. Alright, now what we can do is we can open a window. This will actually, well, if I move this real quick, you can see this makes a window object which is unique to this module. It does use the OpenCV function to do it, but it makes it so it's threaded so you don't have to deal with it, the updating and stuff. We start it, which of course you have to make sure you stop it or it's going to give you a problem. And then we have to add it. So we put the name of the window we want, which you can see right here is cornfield. Then we put the image and we just press enter, and we have the two images we made. It returns the name here. If there's a conflict, it will make it look like sunset, one like that or something. And that's good with the windows. Now we can also do some actual manipulation. Like this, we can make this image gray. Keep in mind when we are making the image gray, we're not actually changing x1. Okay, so x1 is still the exact same. You would have to change it like this if you want to actually change x1. Alright, now we can resize the sunset image like this. And it's so small now. It's right there, pretty small. You can zoom into it with the OpenCV windows. And you can see if you exit off, it just comes back. It's part of the thread. To actually stop it, you'd have to type stop like that with parentheses. Alright, so now we can also increase the size or decrease the size with pyramids. It looks like this when we do it. If we want to increase the size, you can make this 1, 2, 3. If you want to decrease it, you can do that. So we decreased it right there. We can increase it like, oops, gotta remove that negative. Now it's super big, you can't even see it. Yeah, really big. Alright, and we can also decrease it again. Okay, and it's over here. Alright, now we can actually save an image like this, but while we're saving it, I'm going to increase the brightness, and I'm going to do it by 50, so this is 50% more of x1, which is relative, so not to the 0 to not to 255, which is the max value you can have. It's relative to the image. So now we can save it. We can open it up with the Windows viewer of images, and we can look. Now it's a lot brighter than that image right here. Okay, we can also set the brightness like this, and the only difference here is that you can see a value of 20 actually made it not as bright, and that's because this is not adding what is already there. So when we increase, we already are adding x1. This is taking 20% of x1 already, and this is not relative unless we do relative equals true. So now you can see if we do relative, it looks a little better. Relative always makes it a little better. Okay, now we can also look at gamma. We can set gamma like that. And we just made it brighter. We can make it a little brighter, a lot brighter. And we can also make it smaller like this. So now it's super dark. And we can also do some other things that make images look gray. So this is just a normal gray, but we can actually apply this right here, and you can make it look like that. This is down here if we want to actually get what the whole thing stands for. It's down, way down. Oh no, did I pass it? I did pass it. It is right here, yes. Okay, so contrast limited adaptive histogram equalization. That's pretty much meaning it's local equalization. The one I'm about to show you right here is global, which I'll show you as soon as I find my console. Alright, so now you can just do this. Actually, before I show that real quick, I made this image gray. If I open it up again, this one, you can see it's that color. If I actually call this function right here without gray, so I made it gray before, if I do that, you can see it looks really weird. So that's why I don't recommend you actually do that, because I'm doing some hacky stuff. I'm just splitting up the colors into gray, and I'm doing it, so it's not really going to work that well. But we can also equalize like this. I'm not entirely sure if you can equalize. Yeah, you can. So you can compare them if you, which one you kind of like. They look pretty cool. The other one didn't have those weird clouds, so that's with the equalization functions. Now we can actually rotate an image 45 degrees counterclockwise. You can see right there, if we want it to be clockwise, you put a negative. We can translate the image like this with the function translate, which is not going. Okay, you can see I translated it 100 horizontal, 50 down. If you want to move it up, you just add a negative like that. Okay, now we can crop an image like this. We just crop that image. If we do, you can see we cropped it like that. This is actually not my favorite crop function. We have a lot of cropped functions, which are down here. Yeah. The one I just showed you is this one. We can do cropped with chords. We can shrink sides, which I like this one the most. It's a little more easier to understand because you're just shrinking the top side, the bottom side, the left side, the right side. And this one can be kind of good too. It's kind of like a zoom, but it's not resizing, which you can see is the same code used right here. Alright, so to just show a shrink sides real quick, we can do this. We can open up the image we have right there. We can press enter, so we can actually copy and paste. And I can, oops. We can just do that, and there we have that. Okay, and so now we have the image like that. I can show a little change. We can shrink it like that. So we're just like eating away the sides to whatever you want. We can also pad, which is the opposite of this. So now it's going to pad 20 by 20 on each side. They're all going to be black. If we want to change the color, we can put a value here. It's going to be blue, green, red. So if we want it to be mainly blue, we can do something like that. And if we want to make it mainly green, we can do that. And if we want it to be red, we can do that. Okay. Now we can also blend these images, and I'm going to add a new image so we can just compare the two. So they're a little modified, but you can see in this image, you don't see that little sun here, which is actually in this image. You can see this 0.7 here weights x1. So if we do 0.7, it will times x1 by 0.7, x2 by 0.3. We can override it like this if we want to make it a little more, but it's going to increase the brightness of the image. So that's not entirely safe. So what we actually want to do is go like this. You just use this and you can just decrease it like that. So now we're getting a mix of the two, which looks kind of cool, I guess. Alright, and now I just made, you can see I made 3 images, all the same, all without even a name. To delete an image, you can go like this, or I mean a window, you can go like this. So I just deleted one window. Because I overwrote the image, you can put the name, which is found up here, right there, and we can remove it. And I'm going to keep that one. Okay, so now we can zoom. I'm going to zoom into this image right here. So you can see I just zoomed in. the way a zoom works is this is where you want to zoom, so it's an offset from the center of the image. So horizontal, vertical. I think if we can go look at this, and yeah, horizontal, vertical to make sure, and we can put the shape. So the shape is pretty much what size do you want it to be after you zoom in, and you can actually see the code right here. How this works is we crop the image, and then we just resize it to the original shape of the image. This is how I do the zoom. Alright, so now we can also look at some other functions. These are useful. They're mainly for testing purposes, as you can see right here, testing purposes. But they pretty much find like a value. They try to find the most popular values in an image, and they can make all the others like black or something. And we can also do this function right here, which will put it'll find the magnitude spectrum, which can be kind of cool. Actually, let's just do that real quick. So this is going to be the cornfield one. And we can just go like that. Put it in there. Put the cornfield one. Now we can go view the cornfield. And that looks weird. What happened? Okay, so I don't think we're actually supposed to view it like that. That must be what it is. Yeah, let's do this one instead. We can do this. Yeah. Okay, so we can do this one, and now we'll actually see something different. We can see this. So this takes all, I think the edges, if we change this to low, which is false because it's not going to be high, we can see there's not many edges in it. So that's just the frequency filters. We can also create histograms here, which can be pretty useful to put it in bins. We also can make a histogram back projector, which will try to find images similar to themselves. We also have a template matcher, which will try to find a similar image, and it can find multiple, I think, right here, down here. Warning, it does not check if there's overlap. So this function does not work if there's overlaps. If there's like, if we can go look at an image right, oops, not that one. We can look at the sunset. If we wanted to look for the sun here, it might draw multiple rectangles around the sun, whatever looks similar. So this isn't the best function. You could probably make it so there's no overlap, but I didn't add the logic for that. Alright, so now there's the camera class. This class is pretty useful if you're making your own data sets. I've used it several times for my face recognition projects. So you can just make a camera right here. You put the FPS, which device it is. You make it. Make sure to call release when you're done using it. If you don't, it's not the end of the world. It might just pause your command prompt or something. And then you can take a picture like this, and you can record frames like this. Warning here, there's no like frame rate here. Even though we set the frame rate up here, we could be slower or something like that. So if you put like 10 frames, don't expect it to be only last for a certain amount of time. And this is just used for the windows. This is probably the best class we've been using the entire video. You can see you got to start it, you got to stop it, which I'll do in a second. And we can add, set, and remove. And we also have this. This can be pretty useful. This is more of an example. You don't want to actually use this whole thing probably, but you pretty much give this callback whenever you add an image right here, and it will, if I do something with the image, like let's open a better image. If I do this, like draw with my mouse, it will actually could draw if you code it to do that. So you can see with the code here, you could add that. Alright, and this is just the testing stuff you can run to just make sure everything's installed and working properly. So that's pretty much the entire video. In the next video, we may either get into audio manipulation or we'll go straight to Keras and TensorFlow. Okay.